So today we're going to be talking about applications of quadratics.
So, when you have your factors, you replace them right here. Are you going to give us those three variable system blueprints on the class?
So if on the test you're given three sets of points or 3 points, one I would give you, and it was a required question, I would give you the y intercept.
Okay, so you don't have
We would just have a 2 variable, not 3 variable. Because we're going to go over solving 3x3 systems in another chapter. Okay, so we're going to go over various application problems that, in the end, will generate a quadratic equation. So the first one, we have a farmer, and he has 1,600 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that enclose the most area? So when we consider this, well, let's make it rectangular just to, we don't know exactly what the dimensions of the rectangle will be, but I'm just going to draw a rectangular. And we know that opposite sides of a rectangle are congruent, so we'll write those as x. Now, if we know there are 1,600 yards of fence to go around the entire rectangular field, what expression could I use to represent one of the other sides of the fence? Daniel?
800 minus x.
Okay, how do you know that?
Well, if both sides are 800 minus x, then they won't be equal, and if you added all the sides together, it would still add up to 1,600.
Correct. Also, you can think of it this way. If the entire distance around the rectangle is 1,600, then halfway around the rectangle would be 800, because you've gone halfway around. So if halfway around is 800, the remaining side would be 800 minus x. So picture like you're an ant, or I don't know why you have to be an ant, you're you, and you're walking around this perimeter. If you've walked this much, you've walked half the distance, or 800 yards. So if this is x, this would be 800 minus x, which is the remaining amount. So who could tell me what an expression for area would be? Ashley?
So negative x squared plus 800.
Okay, good. So x times 800 minus x, and then Ashley went ahead and multiplied it out. So that is an expression for area in terms of x. And if I just want to write the terms in order, it's negative x squared plus 800x. So I want to maximize the area. So this is a rough sketch of my parabola, where x is the length of one of the sides of my enclosed area, and A is the area that I'm enclosing. So I know this goes through the origin because my y-intercept is 0, and I want to find what value maximizes my area. So in other words, I want to find my vertex. So negative 800 over negative 2. that's the x value of the vertex. And then I look at what the question is in the problem. It says, what are the dimensions of the rectangle that enclose the most area? So the dimensions are 400 by how much? Ollie?
400.
400. Because my other dimension is 800 minus x, which is 400. So it's a 400 yard by 400 yard rectangle, aka a square. Does it surprise you that a square would maximize the area? And really, the most symmetric the object, the most area you can fit in it. Like if we could make this puppy a circle, it would have the most area in it. Okay? Because a circle has none of those corners to kind of box out area. But it says you want to enclose a rectangular field, so that's why we had to have corners there. Because the opposite of this would be something that looked like that. Okay? That's not going to have a lot of area in it. Think of that to the nth degree. Like something so thin that not even like a cow could walk through it. All right? That would not have a lot of area at all. But if we have a perfect square, you're going to maximize your area. So the most symmetric object is going to have the maximal area. So really, these problems are not all that interesting if it's just what rectangular object has the most area, it's going to be a square. But the algebra confirms it. So now we're going to go on to another type of problem, which is one that involves gravity. So we have a motorcycle stunt rider who is jumping across a river. And she has an equation, and this is not that hard to do. All they would have to do is take a video of the jump, do a time lapse, and then superimpose it on a grid. And these days, this would be not very hard to do at all with technology because everything is recorded digitally these days, and you can just simply do a time lapse where you have different images of this particular stunt rider going across the screen, and then you could just write the equation of her jump. And that's her jump, where x is the distance from her launch ramp, and h is the height above the river. And for these problems, I love writing a picture because it's very hard for me to picture what's happening in my head. So that's where I draw a picture of what's happening. So I'm going to do that. So you have a ramp. You have a motorcyclist. Let's put a helmet on it. You have a ramp. Then you have the river. And then what she's going to do, she'll start way back here. Like you're not going to start right there because you're not going to get far. You just start right there. And then she's going to hop off the ramp and hopefully clear the river. That would be a rough landing. Hopefully it's a little less like. And then she'll hit the ground. Gently and hopefully clear the river. And so, since x was her distance from her launch ramp, that means this is going to be where our axis is superimposed. Oh wow, that is not even close to vertical. Can I rotate that? Was my ramp not vertical? Was that my issue here? Okay, how do you feel about that picture?
Looks pretty vertical.
Oh, thanks. Okay. So, how do I answer the question A? How high above the river was the launch ramp? Yes.
Or you just put in 0 for all.
Yeah. So you want to find out what, in other words, the y-intercept is. Oh, that's supposed to be a star. I'm like over in here. That's the y-intercept, because here's our x-axis, or our y-axis, and here's our x-axis. So and it looks like we're in B. So that's no joke. She's really high in the air there. Questions there? How far was the rider from the ramp when she reached her maximum height? How do I find that? Richard?
You find the vertex using negative b over 2.
So it looks around 238 feet along. She's going to hit the highest point of her journey. Oh, did I just write the wrong number down? Okay. So the vertex occurs 239 feet along the journey from that ramp. And then how would I find how high she is above the ground there, or the river? Okay.
You could substitute 239 in for x.
Okay, so if you were to substitute 39 in for x, what would we get?
Don't know. Yeah.
Calculator, let's do it. Whoa, 885.6. So that's pretty dangerous. And some questions we can ask is, if the river is this wide, did she clear the river? We could calculate forces to see if she was able to actually land the motorcycle, because even if you clear the river, if you crash, that's not a great ending. So that's really high up. So, yes. Parabolic motion. on a motorcycle? Questions? So this is the Golden Gate Bridge in San Francisco. I got to see it when I traveled to Stanford University. It is so long. And this is an actual picture of it. So we know some things about it. We know that it is right in front of San Francisco Bay. It's 746 feet tall in terms of the towers. And those towers are 4,200 feet apart. So this tower to this tower right here are 4,200 feet apart. The bridge is suspended from two huge cables more than 3 feet. And do you guys hear that? 3 feet. The cables are 3 feet in diameter. So like 2-year-olds are 3 feet tall. That's how big the cables are in diameter. Just a cable. Okay?
How did they move those?
Yeah, very, very big trucks. The 90-foot roadway is 220 feet above the water. So here's the water, here's the roadway, that's 220 feet above the water. So stay on the bridge when you drive. The cables are parabolic in shape. So here's the parabola. Find the height of the cable above the road at a distance 1,000 feet from the center. Okay, you guys ready to tackle this? So I'm going to scooch this over a little bit. So we have the towers. Boy, I wish that was more symmetric. Let me try again. That's a little better. All right. I'm trying to pick out the important piece of information here. So the towers themselves are 746 feet tall. But do you guys notice that the parabolas don't go all the way that far? The parabolas go only to the roadway. You see that the roadway is not on the water, because that would be silly. It's above, it's a bridge, so it doesn't run like adjacent to the roadway, it's above the roadway. So this distance here to here is not 746, but how much? 526, yep. So what you need to decide at this point is where are you going to put your x and y axes? Yes?
So I think then you can put the y axis on the like one of the supporters, like the huge tower.
You can certainly do that.
Because then we can build the Y.
Sure. Ashley, did you have a different thought?
Put it the y-axis of the distance 1,000 feet.
There's so many ways to do this problem. I was thinking you just put it at the origin or at the vertex, but we don't have to do it that way. You can put it anywhere. Like that's the thing with real life modeling is you can impose your axes wherever you want. So Daniel suggested doing it like here. Ashley suggested putting it 1,000 feet from the center. So like off of the center by 1,000 feet. I thought just threw it right here so that the vertex would be at 0, 0. But I don't know, what do you guys think? Well, we'll take Daniel's suggestion since I called on him first. What's the vertex then? What would those coordinates be? Let's hear from somebody new. Andrew?
2100.
Yeah. That's our vertex. And then we know the bridge, so we can write the equation in vertex form. There's the equation in vertex form. And then how do we solve for A? Noah?
You could do you could have x be 0 and y be 5 to 26.
Okay, so you want to plug in the y-intercept?
Yeah.
So if we plug in 0, 5, 26, we can solve for A. That number is in scientific notation in my calculator. I'm just going to call it like that. I'm going to keep it like that so I don't have to write it in scientific notation. It's going to be positive because you're squaring a number, a real number, so that'll be positive. So that's A. All right, so there's my equation. I'm going to scooch my picture down a little bit. So y equals there's my equation. I don't know what I'm boxing because I'm not done. Find the height of the cable above the road a distance of 1,000 feet from the center. How do I do that? Again, I want to hear from somebody. Okay.
You could plug in 1,000 for x. That is your distance.
Okay. Is x 1,000? If x equals 1,000, are you 1,000 feet from the center?
Oh no.
Okay. So what would you plug in?
You would you could do it two different. Okay, so you could do 1,000 with them.
1,100?
Yeah.
Or what was another?
Or 3,000.
Yep. So either one of those would tell you how high up you would be 1,000 feet from the center. I'll just do the lower one. Either way, whoa, sorry. I guess it's okay. This is just going to be 1,000 or negative 1,000 or 1,000 squared. Anyone else get 119.3 feet? Okay. So you can find the height above the road at any place now. You should get the same answer regardless of where you put your axes. But that's your own creative choice there. Right? But notice how much you had to kind of sift through there because they gave you so much information. It's not like, oh, just pick the numbers in the problem. There were so many numbers, and many of them were not really relevant to the question. They were interesting, but the fact that the roadway is 90 feet wide, that's interesting. Just gives you a sense of how many cars. A lot of people bike across the San Francisco Bridge. They can walk too, but yeah. So parabolas everywhere. Any questions on that?